Hello, everyone. Welcome to DockerCon. My name is Carmen Puccio. I am a Principal Solutions Architect here at Amazon Web Services. I'm actually Docker's Partner Solutions Architect, and I've been their PSA for the better part of 2 years. In my 4 years here at Amazon, I've worked in a variety of roles. I started out as part of our mass migrations team, working with our consulting partners and technology partners, figuring out how to move customers over at scale. And in the last 2 years, I've served as a principal solutions architect, working with our container partners, helping customers adopt container technologies. It's my privilege to talk to you today around access logging and how you can make it easy with Envoy and Fluent Bit. And if you want to reach out or have any conversations, you could always hit me up on Twitter, and you can see my handle down there below. So with that said, I want to kind of set the stage and talk about the benefits of microservices before we can get into the technology portion of today's presentation. Microservices is not necessarily a new concept, so I'm going to do a flyby. The first thing that we talk about is agility. When it comes to the agility factor, microservices foster that organization of small independent teams, and it essentially allows them to take ownership of their services. Teams act within a small and well-understood context and are empowered to work more independently and therefore more quickly. It's done to shorten the development lifecycle and essentially to accelerate the throughput of your applications as you move them to production. The second thing is flexible scaling, and microservices allow each service to be independently scaled to meet the demand for the application feature it supports. This enables teams to right-size their infrastructure, accurately measure the cost of each feature, and maintain availability if a service experiences a spike in demand. Easy deployment is also another benefit, and think about this as essentially the ability to enable continuous integration and continuous delivery, and making it easy to try out new ideas and to roll back if something doesn't work. The low cost of failure enables experimentation, making it easier to update code and accelerate the time to market for new features. We call this the innovation flywheel, and you've probably seen that in many different Amazon slides. Technological freedom is another one, and just because microservices architectures don't follow essentially a one-size-fits-all approach, teams do have the ability and the freedom to choose the best tool to solve their specific problems. And as a consequence, teams building microservices can essentially choose the best tool for each job. Reusable code is another one, and dividing software into small, well-defined modules enables teams to use functions for multiple purposes. And a service written for a certain function can be used as a building block for another feature. And this allows applications to bootstrap off themselves as developers essentially create new capabilities without writing code from scratch. And lastly is resilience, right? So when you talk about microservices, each service is essentially, think of it as an independent resource. And you need to think about how you can essentially build an application and make it resilient to failure. And in a monolithic application, if a single component fails, it causes the entire application to fail. With microservices, applications essentially handle total service failure by degrading functionality and not just crashing the entire application. So with that said, I think this picture says it all. If you imagine having an environment with hundreds to thousands of microservices, hopefully this picture resonates with you. And if you take a step back and you think about traditional three-tiered web applications, the communication model isn't complex. It was essentially 2 hops. And you usually have like front-end web application, and it's communicating with a business layer and a data layer. Move towards like the present day where organizations are building cloud-native applications via a microservices approach, where each microservice is a small shippable service running in a group of containers that scales independently via an orchestrator, and the communication between these services now becomes really, really complex. And this is why customers are looking to service meshes. And service meshes are a software layer that handles all of the communications between these services. And it provides essentially the new features to connect and manage connections between services, and is independent of each service's code, allowing it to work across network boundaries and essentially with multiple service management systems. And if you think about the previous slide, where one of the benefits of microservices is your teams have the freedom to choose the best tool for each job, hopefully one of the big challenges pops in your mind with that scenario, and that's what we're here to talk about today. And it's logging, right? So one of the challenges of a polyglot microservices architecture is trying to correlate different access logs into a consistent format as they're sent to a centralized logging solution. Imagine trying to find a particular error or a status code for different services that are interacting with each other with no data consistency in your logs. And moreover, trying to find and maintain all of the different parsers you need to ingest that data into a logging solution. You really don't want to waste cycles here for your teams, because essentially it's taking away from the innovation and the quicker time to market that microservices architectures are supposed to bring your organization, if you think about the benefits before. So in the past, what you would see is people like SSHing into various different servers, trying to search and diagnose issues. And while this worked in the old world, where infrastructure was essentially a pet, it doesn't work in the modern world, as you know, with containers and microservices. It's not feasible. An application running in a container can have a very short lifespan and can run across any number of nodes within a cluster, which means that the need for centralized logging is a mandatory component in any enterprise system. And the benefit here is now you not only have the ability to centralize all of your logs in one place, but you also can essentially work to correlate logs across your application portfolio to get a greater picture of what happened exactly in your environment. But the question is like, how do I do this? How do I get it into a consistent structured format? And what technologies can help, right? So the first one we'll talk about is Envoy. For those who don't know, Envoy is an open source edge and service proxy, and it was designed for cloud native applications. It was originally built by Lyft and graduated as, I believe, the third project into the CNCF following Kubernetes and Prometheus. And to move from that maturity level of incubation to graduation, projects have to demonstrate things like thriving adoption and essentially like a neutral governance process, multi-organization commitments, and a community support in terms of sustainability, inclusivity. Envoy runs along every application and abstracts the network by providing common features in a platform agnostic manner. So it has features that you would expect from a mature proxy, like advanced load balancing and observability with a robust set of APIs to enable configuration management. When all of the service traffic in an infrastructure flows via an Envoy mesh, it becomes very easy to visualize problems in terms of consistent observability, and it gives you the ability to tune your overall performance and add or change features in a singular place. And you might be asking yourself, okay, so like, why a sidecar proxy? How does that help me? And isn't that just another piece of code? And the benefits of running a sidecar proxy are that you can install and upgrade it independently of your application code because it's not tied to your applications. Your developers aren't forced to use a particular library or an SDK, and the configuration of the proxy is independent of the configuration and business logic for your applications. The proxies have their own business logic and their own configuration. So separating at that layer minimizes inconsistencies, even if your teams and services basically, if they're using various different language or different compute platforms, it doesn't matter, right? Having that same proxy running everywhere down to the same specific version enables you to have a consistent configuration throughout your services, independent of language or platforms, and regardless of what your different service teams are using. So I'm going to do a flyby on AWS App Mesh. This isn't a talk on App Mesh. I just want to kind of highlight that we do use the Envoy proxy. And for those that don't know, AWS App Mesh is a service mesh which allows you to gain visibility between various services in your environment, all while making it easy to monitor and control and debug the communications between those services. So again, like I said, App Mesh uses Envoy as the proxy in front of your containers in a service mesh, and it allows you to generate access logs in a consistent format. So a simple example, as you see here, would be you have two services, Service A and Service B, and Service A is making, say, layer 7 HTTP requests to Service B. And if you want to log the request to Service B, I could easily, obviously, just turn on logs. But what happens, again, if you think about that picture before, if I had hundreds of services and they're in a polyglot fashion? So how could I force the teams to achieve uniform logs? Standardized logging via an SDK is one way, but then again, the challenge of getting people to bring it into their app, keep it up to date, it's troublesome, right? So the same challenge happens with metrics and tracing. Perhaps like you're counting something like the number of requests that succeeded or failed, and you want to get uniform metrics across all of those services. Or perhaps you want to trace a request as it essentially traverses through all of those services. Even in a simple example like you see here, where one service is making requests to another, this could be difficult. Because imagine service B has multiple endpoints and it's running as a Kubernetes service, or it's running on Amazon ECS or Fargate. And there really could be anywhere from tens to hundreds of containers that are part of service B. And if I'm load balancing all those containers, I don't want to have to build in load balancing into my app code, because then I have to write my own load balancing, or again, download an SDK and make sure all of my teams are up to date again, make sure everybody's at the same version. Ideally, what you want to do is you want load balancing done for you, so that when service B team rolls out a net new version of their service, they want all their clients to start using that new version in a controlled manner, where only a small percentage of the traffic is routed to service B. So the team can observe essentially that net new functionality in production. And the point here is all your teams, they essentially, they're tightly coupled to each other, because it becomes difficult to do things like new releases, because you need to communicate and have them sign off. You want to be able to iterate independently, and also, not have to worry about the heavy lifting of things like load balancing and traffic shifting and logging. And let them focus on what they're good at, which is application code itself. And this is the focus of AppMesh. And this is the last thing I'll say about AppMesh before we get into just Fluent Bit and Envoy as a whole. AppMesh is essentially application level networking that works across various different compute primitives in AWS. And I want to emphasize, and the one thing that you could take away from the presentation today, besides what I'm going to teach you next, is AppMesh works across our compute services. And it's not tied to a specific container orchestrator or a compute primitive. So it works in Amazon ECS, which is our native container orchestrator. It works with AWS Fargate, which is our serverless container platform. It works with Amazon EKS, which is our managed Kubernetes platform. And it even works with services that are running on EC2 and containers, or even an individual process. And lastly, if you're running your own Kubernetes cluster, it works there as well. Right? So keep in mind that it can work equally well across all of these services and is not specifically tied to one container platform. So to go another level deeper now, let's talk about the Envoy access logs. And this is essentially the guts of the talk. As you can see here, Envoy as a proxy is simply a container that's intercepting traffic to your application in the mesh. And regardless of the backend, Envoy has its own version of access logs, which gets you towards that path of standardization that I was talking about. So when it comes to access logs and the format of those logs, the Envoy proxy uses what's called format strings when generating access logs, which are essentially just plain strings that include the details of an HTTP request. And as you can see in the slide, the Envoy access log format is similar to what you've seen from other access logs. And you could also see here that the JSON is escaped into a singular log entry. And in order to make it meaningful, you need to unescape it, and you need to add structure around the data itself. So this is where Fluent Bit comes in, right? So, if you haven't seen Fluent Bit, let's just kind of talk about it at a high level. And I also want to mention Fluent D. Fluent D was created by Treasure Data and is an open source data collector for unified logging. And think of it as it's essentially very common to use Fluent D when handling in logs like something like Kubernetes. We have a lot of customers that are doing essentially that model where they're using Fluent D to forward their logs out. Fluent Bit is also an open source project created by Treasure Data, and you can think of it almost as a sister project to Fluent D. So much so that Fluent Bit provides an output plugin to flush information to Fluent D. Think of it in terms of an aggregator, if you will. So they can work together as in your architecture, almost as independent services. And here at AWS, what we've done is we've begun to integrate Fluent Bit with our container services because we feel it's lightweight due to its lightweight nature, essentially. And while the Fluent Bit documentation has a comparison stating that Fluent D scope is mainly for servers and Fluent Bit scope is mainly for things like embedded or IoT devices, we've built integrations around services like Amazon ECS and ECS for Fargate for Fluent Bit to handle things like ingesting and parsing and filtering and outputting your logs. We're seeing customers adopt Fluent Bit on their Kubernetes workloads as well. And as you can see here, it has more than 50 built-in plugins available. And what we've done is we've worked with our AWS partners to add support in their solutions to make it easier to integrate and send log data for our customers. So I want to go into the Fluent Bit pipeline and how it works, and then we'll get into the logging format, right? So this diagram shows Fluent Bit and its internal log processing pipeline architecture. And it's important to understand the internals of how this works as you plan your implementation. The first thing you have is obviously your input, and input plugins are used to gather information from different sources. Some of them just to collect data from log files, while others can gather things like metrics information from the operating system. When we talk about gathering logs in this talk, though, it's going to be essentially around the tail input plugin, which really just does that. It's tailing a file or a series of folders and files for new log entry. And then you have the parser. And this is a very crucial piece to understand. As log data is streamed from your applications, you need to essentially parse it to a format that's valuable to you, right? Meaning you want this data structured. You want the information that's important to you inside of these log entries. And then you need to think about how you're going to filter it, right? And think of filtering as how you would match or exclude or even enrich your logs with some specific metadata. And a very common use case here for filtering is Kubernetes deployments. Every pod log essentially, needs to get the proper metadata associated with it. When we talk about this, in the upcoming slides, I'll go into it in more detail. But you need to think about filtering as how you're going to enrich, right? And how you're going to send things to different places at the same time. Because then you get to your buffering. And buffering is essentially a way to handle either too much data coming in or potentially an unstable network, which might result in things like, a delay in sending data. FluentBit uses a primary buffering mechanism in memory and also has a secondary one, which is optional, which allows you to use the file system. And then you have routing. And this is a core feature that allows you to route your data through filters and finally to one or more destinations. And the router relies on concepts like tags and matching rules, which we're not going to go into today, but it's a really powerful feature. And then lastly, you have outputs. And FluentBit ships with a number of output plugins. And again, we've worked with AWS partners to make it easier to ship your logs from FluentBit to their solutions. So this is the pipeline. And if you think about your logs coming in, you might be asking yourself, okay, like what about Kubernetes, right? So, when it comes to Kubernetes, and to dive in a little bit here, you can see here there's this concept called cluster level logging. And it's important to realize that your logs should have essentially a separate storage and lifecycle independent of your nodes, pods or containers. And this essentially means because you need to think about how you're going to get your logs to a centralized location so you can store, analyze, and query your logs, because Kubernetes does not provide native storage for long-term data. There are a couple of ways to approach this, but the most common and encouraged approach is to do what's called node level logging. And you can see here, customers achieve this by running a daemon set on their clusters because it creates an agent per node, and it doesn't require any changes to the applications running on that node. However, node level logging, as you can see here, only works for applications that are emitting over standard out and standard error. And anybody who really has dove into container best practices should know that you should always try and log the standard out or standard error anyway, because your containers don't necessarily need to have to read and write to a log file, which, it's going to result in a performance gain. Not to mention you're abstracting away the management of those logs within the container itself, because you don't want to store logs in a container. It's bad practice, right? This is because you never know when that container is going to terminate. When using node level logging, you can see the logs are shipped to the following path, and the nodes in Kubernetes implement essentially a log rotation mechanism. And when a container is evicted from the node, all the containers with corresponding log files are also evicted. So when FluentBit is deployed in Kubernetes as a daemon set and configured to read the log files from the containers, whether, again, it's using Tail or one of the other input plugins, FluentBit has what's called a Kubernetes filter, which allows you to enrich your log files with Kubernetes metadata. And the filter aims to perform the following operations. The first thing it's going to do is it's going to analyze the tag and enrich the following metadata. It's going to get the pod name, the namespace, the container name, and the container ID. And then what it's going to do is it's going to query the Kubernetes API server to obtain the extra metadata for the pod in question. And this is because pods aren't essentially like node level. You have to get this information from the API server. So to be able to get things like the pod ID, the labels, the annotation, this is really, really important, right? Especially if you're spread across a bunch of different nodes for your application. And the cool thing here is the data is cached locally in memory, and it's appended to each record as these logs traverse through your system. So you might be asking yourself, like, with all this said, how does this help me with Envoy access logs? And as you can see here, the data in the log message is Envoy's default access log, but the JSON is escaped. And in order to parse the log into something that's meaningful, we need to run it through a parser in Fluent Bit. And Fluent Bit ships with some default parsers that are commonly seen in applications. And at the same time, you can always obviously write your own. I actually contributed the Envoy parser back to the project back in February 2020. And this means that the official Fluent Bit image and the AWS for Fluent Bit Docker images already have this for you out of the box now. And you can easily wire it up in your environment, which I'm going to show you how to do. And as you can see here, all it is simply a regex that's going to match the default Envoy format. And the goal here is not just to parse the message, it's a stepping stone to put structure into our logs. So in order to use this parser with your applications, you can leverage what I think is actually one of the cooler features in Fluent Bit. And in this example, we've defined our application in Kubernetes via a manifest. And you'll notice our application's deployment spec, we've added an annotation with a value of Fluent Bit parser Envoy. And this annotation suggests that the data that's processed uses what's called a predefined parser called Envoy. The fact that the parser exists in our Fluent Bit image means we don't have to do anything else in order to use it. And if we were writing our own custom parser, we could do the same thing very easily by writing it via things like config map for our Fluent Bit daemon set deployment, and then obviously reference it directly as you see here in the manifest. Outside of the predefined parser suggestion, you could always wire up the parsing as part of the Fluent Bit pipeline that I described earlier. But by far, this is the simplest way to leverage it in your applications, in my opinion, is just to use this targeted parser, if you will. So now that we walked through this step, it's time to look at some of the useful information you get by leveraging Fluent Bit. To start, here's the Kubernetes metadata for a log entry. It was way too much to fit this into one screen, so I had to break it up. You'll notice the log that you've seen before now has all of our Kubernetes context. And the lesson that you need to take away from this is any log processor you run in a dynamic environment in the cloud needs to be aware of how to enrich your logs metadata. Otherwise, you're going to lose this context about what happened and where. And now you have access to things like namespaces, and pods IDs, and the node it ran on, and all the useful information your teams will need when doing any troubleshooting or analysis. And here's the second part of the log. Again, it was too much to fit on one screen. And here's the parse log entry itself. And again, it's the same log, but it's now sitting inside of a parse key called log process. And the reason for this is when essentially you turn merge log on in your Fluent Bit config, the filter tries to assume the log field for the incoming message is a JSON string, and it makes it into a structured representation of it at the same level of the log in the map. So, the fact that I have this turned on, it's going to dump everything into log process, and it's inserted into that key. So all of these, key value pairs are essentially now nice and clean underneath this log process key inside of our log message. And lastly, here's a view of the final implementation. And our applications are now fronted with Envoy and are communicating with each other as part of AWS App Mesh in this example. And those Envoy proxies are essentially running as sidecars for our application pods, and their access logs are all being emitted out over standard out and standard error. And all of the node level logging is being handled by Fluent Bit running as a daemon set, which in turn ingests and parses and filters. And you're now ready to take advantage of any of the output plugins that come with Fluent Bit. So as I said before, you could send things down to something like maybe an Elasticsearch. You could send it to a partner tool. You could send it to something like Amazon CloudWatch. There's all sorts of possibilities at this point once you get to this model. And while I didn't demonstrate it today, the one thing that's cool is the AWS for Fluent Bit Docker image comes with some built-in plugins to interact with our native services. So if you want to send things to Kinesis Firehose or CloudWatch logs or Kinesis streams, that's all right in the image that we maintain. Again, it is the upstream version of the Fluent Bit image. We just put these parsers, or I'm sorry, these output plugins in there for you to make it easy for you to wire up as part of your implementation. You also have the ability as well, if you were doing this in something outside of Kubernetes, we have a service called AWS FireLens or FireLens, which is actually, it's not even really a service, it's just a layer inside of things like Amazon ECS and Fargate that allows you to leverage the Fluent Bit functionality natively inside of Amazon ECS and Fargate using, you're essentially wiring it up via your task definition. You're still using the Docker image, the AWS for Fluent Bit Docker image, or you can even roll your own. But we essentially make it very easy for you to write, whether it be parsers or filters, and have that be part of your application as you're wiring up your logs and sending them to various different destinations, whether they be AWS destinations or partner destinations. So in conclusion, I hope you've learned how easy it is to implement a consistent and structured log format for the access logs for your microservices applications. Again, some of this was geared around AppMesh, but in reality, you could achieve this with Envoy and Fluent Bit. And as you can see here, it doesn't really matter what container orchestrator or what languages your teams choose. Leveraging the out-of-the-box functionality that's provided, again, with Envoy access logs, it gives you that foundation to implement a consistent logging structure in your environment with Fluent Bit. If you want to learn a little bit more, the premise of this talk was done, it was based off a blog that I wrote about a month and a half ago. The link is here. It's access logging made easy with AWS, AppMesh, and Fluent Bit, so super easy to find on the containers page on AWS. If you want to learn more about AppMesh, I have the link here as well. FireLens, again, it's that abstraction of making it easy to wire up Fluent Bit as part of your application's deployment into something like Amazon ECS. We have some logs here. And at the same time, too, we have some examples. So if you want to go and you want to dive into whether it be Amazon ECS FireLens examples, or how you could actually put Fluent Bit in something like Amazon EKS and do it in Kubernetes, we have some great examples up on our GitHub pages. And at the same time, too, we've had our partners contribute back to showcase how you can actually interact with our various different partner tools as part of your Fluent Bit deployment inside of AWS, how you can easily wire all that up. And that's all sitting inside of the GitHub pages that you see here. So with that said, I just want to say thank you. It's been my pleasure to give this talk. It's a shame I couldn't give it in person, but hopefully you found it useful. Again, if you have any questions, feel free to ping me on Twitter, and enjoy the rest of your conference. Thank you very much.